Hey, if as you're waiting for me to start, you can like actually go to this URL to get all the files sent to your email. When you go here, when they ask what organization, you'll see like ImpactWhit. No problem. If you check in, you'll get all these files and you can do it without me. So I'm just telling everyone, as I wait to start, you can like go to the check-in and all the information I'm about to share will be sent to your email. Okay. So you can do that 85 minutes later. Yeah, that is.
Take care. Hello? Take care.
What's the name?
Hackrates. Hackrates.
Oh.
Building a block rating app. Let me screenshot this.
Bien sûr, chaque chose qu'elle fait, ça t'inquiète pas. Bien sûr, c'est le petit copain d'un copain à moi au travail. Apparemment, il est bon. Apparemment, de toute façon, la situation est plus grave que ce qu'elle est, elle peut pas. Ça ne va pas être pire que ça. Ça ne marche pas. Si tu te donnes des trucs trop graves, moi, je vais. Si, ce sera pas. Mais j'ai des gens. Ouais.
You know, speak French with a Hebrew accent. Slightly. I heard a little stuff in there.
Parce que French, c'est.
Really?
When
When a very Russian person speaks Hebrew, you can always tell if they're speaking Hebrew very Russian. I don't know. Even if I don't know Hebrew.
Yeah.
So,
All have.
That's something that I think. It's almost like something
Still at my school. So.
that's good. Gabriel? Travis, I'll be right. I'll come to you in a minute, okay? I'm coming in a minute, okay?
Damn, she's so fresh. Like, very peaceful. Wait, wait. I was like, usually it's for class. Like, their slides are so good. Like, you make those?
No, it's MLH.
Oh, it's MLH.
Yeah.
Yeah.
Perfect like Microsoft or they get feedback. An experience of you. Now I'll follow up with some of my introduction slides. That's okay.
I don't know. I wanted to like.
I'm trying to record it.
Oh yeah.
Exactly.
Let me know if that's working.
Yeah, it's exactly.
You should apply to the Emily or not. Yeah. So, coach class. Yeah, and then I guess just to do all my friends.
Oh, yeah, it's for that.
Everyone else was able to check.
And we just say TavTech.
I message it to the website of ImpactWhit.
If we say TavTech.
ImpactWhit.
Okay. I think I. Like, if you really don't want to do too much.
One. This?
So I can see the.
Oh, got it. Okay. Awesome. Anyone else had issues checking in? All good to go?
Ready?
Ready? Everyone got an email? Not yet? Awesome.
Yes.
Will you check it?
Yeah.
Awesome. So you got your email? Yes. Sorry, Papa? Why is it showing like this?
Okay, because on my hand.
What happened? You didn't get an email yet?
For this. Here. Yeah. Kind of.
Yeah.
Okay, so quick survey. Who knows about blockchain? Okay. How in depth do you all want me to go about the definition of blockchain? From a scale of like 1 to 5, where 5 is like in depth and 1 is like just an overview. 3? Okay. Yeah.
1.5.
1.5. Okay, so I have a separate presentation for exactly what blockchain is. When you all think it's like too much, just tell me. Let's get back to the workshop, right? Okay.
Everybody, please come together. We'll be learning today about blockchain.
Thank you, Travis.
Please come to the center of the room.
Thanks. I'll take over now.
Can I like whether you want it or not?
Yeah.
No, I'm like, okay, yeah, I'm just putting my shirt in there and like hoping I don't annoy anyone. But like, just fancy. And then, did we need to log in? You never need to log in. Wait, actually, it's
For the newcomers, you can go to this link to check in. I also posted a link in the WhatsApp, and that way you can get your own files in your email.
That's a good question. And I need to speak to the whole staff to figure that out.
Yeah.
What's up?
Wow. First fellow lecturer. Woo!
Hi, was everyone able to check in for the newcomers? So if you go to this link, you can check in. The link is also posted in WhatsApp, so you don't have to like type it out. Yeah.
Third the screen.
This is under organizations. I guess, yeah, that was
Cool.
yeah.
So we do
Not bad.
What happened?
Yeah, that's a good question.
Okay.
Right now, I'm like, I want to put that in my backpack, so I'll just sit in the backpack.
Oh, it's all.
Yeah.
First.
Wait, this is my new sign up. Okay. Okay, I'm gonna begin. For those who haven't checked in yet, you can like catch up afterwards. Is that okay? Awesome. So back to the beginning. Everyone, welcome to Build a Blockchain Ratings app with Microsoft Azure. I'm so happy that you all came in and stayed for this workshop after a very long day. This is a Major League Hacking local host workshop. Before I get started, I want to let you all know that all of you all can go back to your campus and host this, as well as we have a plethora of other workshops across like web app development, data stuff, Slack, you could build Slack bots and so forth. And all you have to do is sign up at the link and you can like schedule it at your local campus. Wi-Fi, everyone should be connected. I ask that you all tweet throughout the event. These are the hashtags: ImpactWhit, MLH localhost, TavTech 19. Is it 19 or 18, Phil? 19, yes. Twitter handles ImpactWhit, MLH hacks. And that way we can create some sort of social media buzz around this. So to get started, once again, my name is Whitney Griffith. I'm here to lead this session. I'm a developer evangelist at Major League Hacking, Microsoft, and ImpactWhit, and this is pretty much my job, like doing stuff like this. This is what we'll be covering today. Intro to blockchain, intro to Ethereum, which is a type of blockchain. You'll create our very own blockchain on Azure. You'll create a bunch of other stuff that will enable us to create an overall decentralized application and deploy it. So once again, check in. This way you can receive all these files, and even if you get lost throughout my presentation, or if you don't want to like pay attention or so, you can do this on your own. The workshops are very like self-explanatory and so on. And even if you want to leave like throughout, it's totally fine as well. No?
Yeah.
Okay. So what is Major League Hacking? For those who never attended hackathons, we are like the official student hackathon league in North America and Europe. And our whole mission is to empower hackers like yourself. And we have over 65,000 hackers in our network, over 12,000 projects created, and we had over 3,000 schools. And I hope you learned something awesome today. So once again, you will learn a working definition of blockchain. Like everyone should leave here having some sort of understanding of blockchain. And if you don't, tell me so I can do that better. How to use Visual Studio Code. This is not necessarily mandatory. You can stick with your own preferred IDE. It's just Microsoft sponsored this, hence I'm promoting Microsoft Visual Studio Code. And how to edit and deploy a blockchain app. Before I move further, I want to show you all the completed application. Where is it? Let's see. So this is what we're building. We are building our Rate My Hack. Maybe you could rate TavTech. We can convert it to like rate Tav. Or we could use this at the hackathon, right? And so you'll see like a list of different projects we submit. We can go in here, and each one of us could submit our very own rating for the hackathon, based on like creativity, technical complexity, and so forth. And once we submit this, I guess we have to vote for all. It will be published to the Ethereum network, and over time, all the votes that was published will be compiled and anyone will be able to access it. So this is the finished project. Sorry for all the slides. Cool. So how exactly will we build this? We'll be using Node.js and Express.js, which is frameworks built upon JavaScript, backend frameworks specifically. We'll be using Ethereum and Solidity. Ethereum is a type of blockchain. I guess you all will be familiar with it in terms of like trading, cryptocurrency, and so forth. But it's also one of the most popular blockchains that you could create applications on. Solidity is the language that you use to create like the different functions, smart contracts on the blockchain. It is similar to JavaScript and all those other languages. So it's pretty familiar. It's just something else that you can like just learn the syntax for and go along with it. We'll be using MetaMask, which is a Google Chrome plugin to be able to manage your wallets, all your cryptocurrencies and so forth that you'll need to be able to submit transactions. We'll be using Microsoft Azure as our blockchain as a service. And so what this does is instead of having to build your very own blockchain and put it on your local computer, which is a lot, you are able to use the cloud, leverage the cloud, and it takes care of a lot of the backend stuff without you even having to think of it. And I'll be using Visual Studio Code. You can use it if you so desire. So what exactly is a blockchain? This definition is pretty technical. So I'm going to switch to my other slides. But before I do that, anyone have a really cool definition of a blockchain? Like simplistic. Anyone? Okay, I will move on. Decentralized?
Protocol.
A decentralized protocol. That's coming from a tech person. So let's see. How I describe a blockchain is pretty much this. I can do this definition first and I can break it down. So blockchain is a way for an internet user to transfer a unique piece of digital property to another internet user in such a way that that transaction is guaranteed to be safe, secure. Everyone within the blockchain and that network knows that it occurred, and nobody could challenge the legitimacy of the transfer in the sense that no one could say this never happened or never occurred. Also, the most important part of this, it prevents double spending. And an example of double spending is, let's say you're trying to go to a party and you're in a Facebook group and someone is like, I have extra tickets to sell. And you slide in their DM and you'll be like, hey, can I get that ticket? So they'll be like, okay, cool. Like, you could Venmo me and I'll email you the ticket. So you have no guarantee that person didn't do that transaction 10 times and got scammed, right? But on the blockchain, there's no way for you to fragment that event ticket more than one time because that's one unique property and you can't send it more than once. So that's like the most marvelous thing about blockchain. as well as the fact that it's decentralized, where you no longer have to trust something like Microsoft or Google to like hold your data. It's open to the public and everyone could partake accordingly. A more simplistic version, I guess, is you can picture blockchain as like T-Mobile, which is one of the phone networks in the US. And each phone or each person that has a T-Mobile account is a node or someone that supports that network. And in supporting that, you have access to like messages, you have access to phone calls and so on. And you just create a really cool network of T-Mobile users. So I can continue on if you like in terms of going through the history of blockchain and so forth, but let's see a vote of hands to know if you want me to go really in depth in blockchain or just continue with the workshop. Who wants to go in depth in blockchain? Oh, no, me too. Awesome. And even if I'm going in depth, you still have the workshop slides where you can do it on your own time. So continue on with this. Blocks, what a block is a block can be either one transaction that occurred in the network or a compilation of transactions in one block. What decides what goes into a block is the specific blockchain. One blockchain that we are going to use today is Ethereum, and that Ethereum protocol decides how much transactions will be recorded in one block. Once the number of transactions is met in this one block, it joins the blockchain, hence the term blockchain, which is a whole chain of blocks. And this blockchain is held in a network. So everyone in the T-Mobile network has access to the blockchain of T-Mobile network. Another cool aspect of blockchain is that it's a distributed ledger, which is pretty much similar to saying it's decentralized. In a sense, for a ledger is pretty much like a record of everything that occurred. So you have this record of everything that occurred, but now you have it distributed in the sense that everyone in that network have that record in their possession or access to it. Other aspects of blockchain, it could be public, which means anyone could read or write to it, or it could be permissioned, which means whoever created that blockchain, it could be me, you, whoever created that blockchain, that person will create the rules in terms of, okay, who are able to read it, who are able to write it. A good example is if a bank decides to create a blockchain to handle their financial transactions, they don't want everyone in the public reading that, so therefore they will make a permissioned blockchain. The read or write access ties into the type of blockchain that it is, as well as another really cool aspect of blockchain is the permanency of data. Once something is written to the blockchain, it cannot be removed. It's immutable, as well as the fact that it even made it on the blockchain, that meant it was a valid transaction. So this blockchain will always have a bunch of valid transactions that can never be refuted or, yeah. And another aspect of blockchain, or like why blockchain is so big now, is that everyone thinks this is like the solution of facilitating trust. In the sense that, back to the whole Facebook example of trying to buy a ticket, you were forced to trust that person who was selling you that ticket. But now with the blockchain, you don't even need to trust that person because you trust the system in which it's occurring on, and therefore trust is facilitated and trust is achieved. So in big picture stuff, sorry.
I have a question about the permanency of data. How do you deal with the accumulated immutable storage, which, I mean, and how long do you keep it forever, or do you keep it for a limited amount of time?
So that question is specific per blockchain as well, but that's one of the biggest issues in terms of mass adoption of blockchain, in the sense that, in theory, if you're keeping all this data, it's not really scalable, in the sense that if I'm trying to pull up a blockchain on my phone, it will crash my entire operating system if the whole world is on that blockchain. So each blockchain have a different way of addressing that. One of that is a good example is off-chain data, in the sense that they may just keep the header of the data and send everything else off-chain in like a typical manner. So that's one example, but there's so many different like theoretical research and stuff going into like how exactly we can scale this into mass adoption. Yeah. Any other questions? Cool. So history of blockchain, to me, blockchain is not really like a big invention, as it was like this technology was already existed. It's just someone, specifically Satoshi Nakamoto, or which could either be a he or she or group of persons, they just compiled all these things to make it what it is now. So the idea of a mutual distributed ledger occurred in like 1976. Idea of time stamping a digital document occurred in the 1990s. In 2009 was the first occurrence of Bitcoin, which was the first example of being able to tie this unique asset in such a way that it could always be tracked and immutable and could never have double spend into it. And then in 2015, we got Ethereum, which introduced smart contracts on the blockchain, where you can literally create a contract that actually enforces itself on the blockchain, and that's marvelous, I guess. And now, present day, we have what is being done in terms of optimization of blockchain, such as scaling issues and so on, and just like actually applying the theory of blockchain to like actual use cases such as fintech, supply chain, healthcare, and so on. Any questions thus far?
I have a question. So this might be a good one. The first one is the same Diffie-Hellman paper.
Yes.
Is it like related at all, or they just wrote a whole bunch of stuff on it?
The first one is like, I think this was like this is the key point in the step to the right direction, in the sense that in this paper, it is explored cryptography in such a way that you can like put solid information on the internet and secure it. So it's somewhat related, but it was expanded. I haven't read this paper in full, so that's really sure.
In 2015, you wrote that there is a combining even contract with digital assets. The implementation of legal contracts has been adopted by the industrial sector, being like banks. Nowadays adopt blockchain as something they recognize and validate, or is it still two parallel tracks, and at some point we hope that
it gets? So there are banks who have adopted blockchain internally, and pretty much all companies who want to stay relevant has like a secret blockchain research lab happening in such a way they're trying to figure out how exactly they can transfer their stuff on it. The greatest use case right now is fintech and money transfer, where banks realize if they don't really get on it, a lot of independent parties like myself will like jump in the picture and like try to create an independent bank on the blockchain, where people no longer have to like use their services, pay their monthly fees, and so on. A good example is Singapore. Singapore has a project called Ubin, where they have a bunch of banks like Bank of America, probably even Barclays, and like big top banks that came into this one consortium where they're testing clearinghouse stuff on the blockchain, clearinghouse transactions, and so on. So all companies that want to stay relevant potentially have some blockchain activity happening. And another thing is that when blockchain first came out, like when Satoshi dropped his stuff, a lot of nefarious activities, and people were pretty much screaming, yo, forget about the government, like let's leave the government, like let's stay totally centralized. Like they came out screaming like if they want to get rid of the governments, the banks, and so forth. So therefore the governments, the banks, and all these other regulatory bodies put up like their war flags, and they're like just making it hard for people to like implement solutions now as they catch up. Yeah. Any other questions? Cool. So technical components of blockchain, private key cryptography, which I sort of touched on. It involves authentication in the sense that for a transaction or anyone on the blockchain has a digital identity, and that digital identity is composed of a public key, private key, and that gives you the digital signature. Your public key is public, private key is private, and this is your only in and out of your specific wallet or in the blockchain. If you lose this, or if anyone else have access, they have the same right of ownership to whatever it is you have on that blockchain, and there's no refuting it. For instance, let's say you happen upon 1,000 Bitcoins, and that's stored in a wallet where you have a public key and private key, and someone get access to your private key. That person could transfer that 1,000 Bitcoins to a different wallet, and you have no way to get that back. It's just like a lesson learned in protection. So identity is based on this, and this is how you, back to the initial slide where you can't like refute that a transaction actually occurred. It's because once you submit a transaction, your transaction is stamped with this combination. So everyone in the blockchain always knows where a transaction is originated from based on this signature.
Question. Based on what you said and what I regarded, you mentioned wallet, and I assume it's where people put their money because real life, that's what we do. Are there different kinds of wallets?
Yes. There are different types of wallets. You can even create your own wallet. Like if you really decide to get into the cryptocurrency game and you're very paranoid about security, you can literally code your own wallet for yourself and no one else have access to. Or you can use a wallet that's in the App Store or online or something like that. There are variations of wallets as well in terms of like cold wallet where it's totally offline, because there are some really paranoid people in the space, in the cryptocurrency space, which is a type of blockchain that truly believes that if your money is connected to the internet, it can be stolen. So they like put it offline, they write it on a paper, they put it in a bank vault or something like that to keep it totally safe. And then there are mobile wallets, web app wallets, so on. Go ahead.
So the private key, where did they get it from?
Cryptography, in the sense that you can run, there are multiple libraries that produce, I can get to that afterwards. Yeah. Next technical component is the distributed network that we mentioned. These represent the nodes, and a node is pretty much anyone or anything that is connected to the blockchain, whether that's your phone, your laptop, a server, this, that, the other. And this network, which could be yours, is responsible for authorizing the transactions that occur on the blockchain based on that blockchain specific rules and instructions. So each node on your network processes every transaction. Once you process a transaction, like individually, you're responsible for deriving your conclusion on whether this transaction is valid or not, also based on the blockchain's rule. And then you vote on that conclusion. So for instance, if we have a vote now and you're validated, the majority goes. And the majority that says, yes, this transaction is valid, if that occurs, then that transaction is published to the blockchain. If it's not, then that transaction is discarded as invalid. Is anyone bored already? Should I stop talking about blockchain?
You lost me. You do it again, please, in a different way. You lost me.
What? I'll get back to that. Heidi?
So an example that you showed us, like the workshop to make like ratings and stuff.
Mm-hmm.
So how does do you always have to authorize things? Like, because you said it's just like a rating of an individual person. Is there like an authorization that we're not seeing, or is it always?
So with the workshop that we're about to make, that is a really good question. So Ethereum is a public blockchain. That means that anyone connected to the Ethereum blockchain and wants to serve that authorization process can. One example of doing that is like mining, and that's a whole different conversation where you use computing power to validate stuff. But once, I'm trying to find this workshop, but in the code that we're about to write, we'll write into the Ethereum network in such a way what we are publishing there is the final vote. So each one of you, as you click here and submit your vote for a project, that is pushed to the blockchain. And on the blockchain, there's already, like once we launch our application, the blockchain will have, you can think of it like a box that represents this application specifically. And this box is put on the blockchain when the first person runs it, right? Then let's say I send this URL link to all of y'all for y'all to submit your vote. Once, let's say someone submits a vote, let's say Travis submits a vote for a hackathon project, his vote will go into this box on the blockchain, and that's when it writes to the blockchain. But before it even makes it on the blockchain, the Ethereum network, who decided to authorize or assist in the authorization process, will ensure, hey, this vote is coming from like a valid person with a valid signature. This vote is not coming more than once, because in our code, we're going to say one person, you can only vote once from this address. And it's validating to ensure this actually occurs. And once that occurs, it submits to the box on the Ethereum network. And let's say we want to pull up all the total votes. It will run that box, tally it, and see how much each hackathon project had. And then we'll see it in our application. Does that make sense?
So you said that everything is decentralized.
Everything is decentralized.
So, sometimes the person that created it is like anonymous. They're going to like an alias name. So how do we know that they don't have that they are the centralization of blockchain?
That's a really good question. So let's say Bitcoin per se. We know it's an anonymous person called Satoshi Nakamoto, or however you want to pronounce his last name. It could be a he, she, or a group of persons. No one knows. And supposedly, because they created the blockchain, Bitcoin, they have like probably multiple wallets of a bunch of Bitcoins where any second they can literally just reap the money out of Bitcoin. Or they can even have like a backdoor into Bitcoin to see like people's identity and all the things that supposedly was anonymous. And that's like a big controversy, especially in terms of like the feds and like the US. A lot of governments actually actively searching for Satoshi right now because they think he really has this backdoor, this backdoor where, for instance, like all the drug lords that did transactions, they'll be able to come into this backdoor and see exactly who they were. But we really don't know. But that's the only unknown Bitcoin. Ethereum moving forward, everyone is known. Everyone, you know everything in terms of like what exactly the person who created the blockchain can and cannot do, and so on. So Bitcoin is the biggest controversy. Preston?
So I have a simple question concerning blockchain.
Pardon?
Isn't blockchain and Bitcoin open source?
In theory, yeah, because Bitcoin, like the whole code for Bitcoin is on GitHub, it's public. And if you spend your whole life like literally going through each line and analyze it, you could potentially find a backdoor in the code yourself. And a lot of new blockchains on cryptocurrency, even Ethereum forked from Bitcoin. So like whatever flaw or backdoor that was in Bitcoin could potentially have been carried on to the others. I think it's possible. But then again, yeah. So another flip side of that is the sense that you have access to all the code. Like literally, this is the code of Bitcoin. So what could Satoshi have other than this to get in? Yeah. So if some like backdoor police goes in or like analyzes and sure there isn't any backdoor, it could be safe. Any other questions? To repeat for Travis's sake and anyone else who I lost.
Thank you.
Distributed network, which is every node that is connected to the blockchain. A node is a person, entity, computer, server. This distributed node network is responsible for authorization. And authorization on the blockchain is pretty much ensuring that whatever transaction, the new transaction that is submitted actually abides by the blockchain network rules. In doing so, it derives its own conclusion. Like you, Travis, let's say you are connected to this blockchain, my blockchain per se, and you decide to like authorize transactions. If a new transaction was submitted to it, you'll look at that transaction, you'll come to your very own conclusion on whether this transaction is valid or it makes sense. And based on that conclusion, you'll vote. Let's picture it as like a voting pool. You submit your vote, and at any time, you know the total number of like nodes that are authorizing on the blockchain. So let's say we have 10 total nodes in the blockchain authorizing right now, and you submitted your vote, whether, let's say you voted yes, then the blockchain waits for at least majority of that 10 persons to submit their vote, and let's say it goes to yes, then that transaction will be published to the blockchain. Got it now? Everyone good?
Maybe I missed it, but on the network has reached a consensus. So it means that if somebody is revoking the transaction, it's not registered by the transaction won't be registered as valid. Am I right?
So consensus is the next word we use for like majority vote.
Majority.
Yeah.
Necessarily a veto. So how is the threshold of the majority? Just
51% and above. And that actually, so transaction is only published to the blockchain once the consensus is achieved. So once that majority vote is reached, then it will be published. And once it's published, there's no going back. Even for some reason, in my blockchain where it was 10 persons, let's say some bad party, let's say Meg, decides, to take over my blockchain, and somehow she got her hands on like 6 nodes, and she submits a false vote, she can take over my blockchain because she has majority vote, and that was consensus.
Can you resubmit?
No resub. What do you mean resubmit?
So the blockchain has been rejected by
the transaction has been rejected by the consensus.
Transaction has been rejected by the consensus. Therefore, it won't be added to the blockchain. Can I resubmit the transaction to the blockchain?
Yes, you can continuously submit, and that could potentially even be an attack as well, where you continuously like flood the blockchain waiting pool. Yeah, but if you didn't change anything in terms of how you submitted that transaction, what that transaction is entailed, it will always receive the same consensus unless you do something to change that consensus voting. Yeah. So, back to the workshop?
Yeah.
Awesome. So that's good. So now back to this. So Ethereum is a type of blockchain, and all cryptocurrency you'll hear about is a type of blockchain, and that's not blockchain on a whole. And why not just use a database? They ask. To know when to use blockchain, you ask yourself, do multiple parties share data? Do multiple parties update data? Is the requirement for verification of that data? Can intermediaries like the bank be removed and reduce cost in doing so? And those are like questions you can ask yourself to figure out if you really want to use a blockchain. This app that we're about to make doesn't really need a blockchain. You can literally just use the database as well. Because in each submission that we do to the Ethereum network, it costs money. So creating an app with blockchain technology can be really tricky. Hence, we're using Microsoft Azure in the sense that if you wanted to do this manually, you have to like do a bunch of like protocol connections and so on. But in Microsoft Azure, you just click a button. Everyone created a Microsoft Azure account. Awesome. Anyone didn't? Cool. So if you can open up your Microsoft Azure account, I can open mine so that you can see as well. Have I lost anyone? No? Cool. Great. I highly suggest that you open the Microsoft Azure account in incognito mode. Sometimes that brings up problems. So as we are on our dashboard, we can click create a resource on this side. On your left-hand side, on the top. Everyone seeing create a resource? Cool. You can type Ethereum proof of work consortium.
Type in.
Yeah.
Portal. Go to portal.
You should see this. If you're lost, please let me know. And also we have MD in the crowd who did this workshop already, and he can be of assistance.
Oh, MD, you're amazing.
Everyone got that? Click create. Proof of work. Make sure you click proof of work and not proof of authority. Those are 2 different protocols. All good? Pardon? Yeah, I think it probably still in beta mode. Yeah, probably still in beta mode. But you can still play around with it. Proof of work. So back to like the consensus mechanism, which is the network deriving, well, coming to a conclusion in terms of whether the transaction is valid. There are multiple ways for that blockchain to manage that. One protocol is proof of work, which is using computational power to derive a yes or no. And Bitcoin uses proof of work in the sense that it runs so much mathematical calculations, and like everyone in the network is competing to run a bunch of mathematical calculations where the first portion of it should equal to 1 XXX. I'm not sure, hence I'm saying XXX, but the first portion of the result should be equal to something that pretty much validates that, yes, this is a valid transaction. And why people want to validate Bitcoin is because when you validate a transaction, you could get rewarded a Bitcoin, which is money. So it's sort of like a job. But it also requires a lot of computing power, electricity, and global warming, y'all.
So is that like the same thing as mining?
Yes, so that is where the mining comes in. Mining comes in where you have a bunch of servers that is working 24/7 trying to calculate these mathematical calculations to derive a yes or no before publishing it to the network.
So that's what authenticates transactions? Or?
Yes, in the proof of work protocol.
Okay.
Yeah. Just like mathematical computations. There are a bunch of different protocols like proof of authority and so on that sort of try to get rid of the proof of work, which is requiring so much electricity and computing power. Click create if you didn't already. And click on, make sure you have create new highlighted and not join existing. Under resource prefix, you type lab, or you can name it anything else, but just for the sake of troubleshooting, we can stick with the same names. VM username, you can put admin user. Password, you can create your own password. Make sure it has the uppercase and what you all can see. Also, you have the slides. So if you're straining to see this on the book, you can find it in the slides. This password that you're writing is for your own purpose to like access the stuff. Make sure it has like a weird character like @ and uppercase. And as we deploy this, they will ask for multiple other passwords. I suggest keeping the same one, although it's not secure, but we're just doing this for learning's sake. Once you type your password, make sure it matches. Has anyone passed this up? Your subscription should be Azure for students. If not, you may be charged if you have a credit card attached. And on the resource group, click create new because I'm not sure if you will have a resource group already. Click create new. You can name it whatever you like. I'll use my existing one. Nope. Okay. Everyone good so far? Cool. Then deployment regions, click one. First region should be East US. Click OK. Everyone good? Awesome. Mining nodes. Back to the nodes. You all know what nodes are. And you all know what mining is now too. You click 2 mining nodes. Keep it as standard. Transaction nodes 1. Transaction node storage performance standard. And click OK. You shouldn't have really had to change anything on this slide, on this page. Under Ethereum settings, you enter 123 on the consortium member ID. Network ID, leave it as is. Leave no, you enter the same password just for your sake that you did before. And enter, even though they're asking for Ethereum private key passphrase here, enter the same password just so you can remember. Yeah, for now. But if you're ever doing this for production sake, don't do that. Everyone's all good? Awesome. Then OMS, leave it as enable, create new, and workspace as East US. Are you doing East US? Why are you doing East US? You can I have no idea.
I was asking why we like set East U as the location for like deployment region and for this thing.
My best guess is the workshop was created for North America. It shouldn't have any effect. Shouldn't, in theory, shouldn't have any effect if you change the location. But if you do change location, make sure you change it for all the other things that we entered ECUS for. You should reach to this page that says summary, and you have to wait for validation to be passed. You should, once it passes, you'll see the OK button turns blue, and you can click OK. Everyone, when you get to this point, you'll be like, you can let me know. So, and once we do that, we'll click create, and it will start deployment. It will take forever. Your validation test is taking forever. Okay. So the deployment, I will continue talking in the meanwhile. The deployment to Azure will take roughly 20 minutes. So we'll continue on to set up the other part of the project while that is happening. Your validation test may also take a while. So just keep an eye out on the blue button and let's continue on. So what exactly happened? In Microsoft Azure, it created a virtual machine for us to acquire Ether, which is the currency on Ethereum, or the digital asset of Ethereum. It also made virtual machines to process transactions, as well as it connected all those virtual machines together. So imagine if you had to like do this on your own, you would probably have to be pulling in a bunch of different stuff and then figuring out how to connect those and stuff. Do you know how to do that?
I know.
Yeah.
I think the automation of this is what makes it usable.
Yeah.
Otherwise, it's
too much, and you never get to create an application.
Right.
Everyone validation test was passed. Awesome. So now you've got an Ethereum blockchain network deployed on Azure. You can give yourself a clap on that. So next we'll proceed to creating a MetaMask account, which is pretty much the Chrome extension that we use to manage the Ether and the currency in and out of our application. So if you go to this URL in Google Chrome, you can go back to regular. You can just leave your Microsoft Azure portal in incognito. How are you all feeling? Is it dragging? If you're finished, you can take this time to tweet. Hashtags ImpactWhit, MLH hacks, TavTech 2019. TavTech 19. Also at ImpactWhit and MLH hacks if you want. Anyone else need help? You can raise your hand and either MD or I can come around.
Any general questions about blockchain?
I am at this point where I created something and it's deployed, so you could do it quicker, or you don't have to pick in. I just but you did like so as you're good to go. Yeah. So now I'm just done with my phone. You have to start.
MD, are you good with Microsoft Azure? She has this really weird error, so I'm telling her she can do a refresh and yeah, let's go to everything too.
What's the face?
For some reason, like these questions is like it's like really annoying. But
It's just so like
yeah, I know, right? They have a lot of tweaks to it. still
Yeah,
work
because
in
I don't do
progress.
mine on incognito.
It works. Like it also varies based on like operating system and stuff. So like this thing is just supposed to all go in incognito to avoid some. And if you check,
That's for all of them.
yeah. And if you should have like so let me know. Anyone else have any issues with Azure deployment? Cool. So if you already added this to your Chrome extension, you add extension, click continue. Let me know if I'm going too slow or too fast. Okay. Create password. Someone had a question? No? Create password. Click next. Accept. Accept. Did you all do this already? Okay, cool. Okay. Click accept again. And here you'll see like a secret backup phrase. Did you all see this? Got here? Past there? Good. Cool. You save that and then you have to re-enter it here. Everyone did that? Anyone didn't do that as yet? Cool. Click out of this. We're not doing anything with this as yet. And MetaMask should be all set up if you made it that far. You should be good to go once you figure out the best way to do it. Cool. So Visual Studio Code, if you do desire to use it. Okay, so the next important step is to navigate to this URL. And sure. Everyone up to speed? Who isn't up to speed so far? Meg, Travis, Jazz. Who is up to speed? You can navigate to this URL. Once you load it, it will download. It will download the code file. You can unzip it and open it up into your IDE of choice. Prefer to be Visual Studio Code.
Once you submit the code, we exit out of this and we're all good to go.
So now we navigate to this website and it will download it. You can leave it open. No data between MLH and
Thank you. No problem. Yes.
Good to go, right? So, awesome.
Oh, so you guys for consistency. Yeah. It's like just physiologically incorrect, but
Once you have the file downloaded, open it up in your IDE.
Is it a CR down?
Pardon? Once you
if you have Wednesday, or
You
where
use it.
you yeah, you have Wednesday.
did you load it?
Is there
Here we go.
second,
It
is
was
there
in
like
this
another
thing.
option?
Windows.
Besides Wednesday, like built in?
Yeah.
Oh yeah.
Everyone up to speed? Who doesn't have it downloaded? Okay. Yeah.
Wait, so after
I've been back there for 9 hours.
And you edit it.
Oh, wait. That's it. Okay.
So I would say.
You can also just talk
Close.
about it.
100%.
Good to go?
I'm trying to record my
Anyone else
Yeah, I'm
is
trying.
up to speed as yet? Cool. That's you. So what's exactly you should be seeing in this project in your ID, hopefully, is a public folder, a truffle folder, get-to-know index.js package.json. If you have that, you have the correct folder open. The public, it runs the files the browser needs to display your web app. Index.js is the main file that runs our application. Package.json is the node packages that we'll be downloading. The truffle folder specifically contains the smart contracts that we will be developing, or as well as, and those contracts is a Hackrates.sol, which records each vote. That's a smart contract that is responsible for recording each vote that is submitted to the application. And migrations.sol is more about like, it's just stuff about Solidity and so on that is needed. If I didn't go into what a smart contract is, a smart contract is pretty much a function that is written on a blockchain that not only, I think I have a slide that says this. Yeah. So Solidity is the contract-oriented programming language used to develop on the blockchain. It was created specifically for making smart contracts, and it was heavily influenced by like C++, JavaScript, and all the languages we are familiar with. You can find more documentation if you want to go into Solidity at this website. And me personally, I did a Crypto Zombies course, which is like a really, are you familiar with Code Academy? It's like the crypto version of Code Academy. For you to learn Solidity is really cool. And that's how I learned like Solidity and got comfortable in it. As well as you don't really need to learn it. If you know you want to write a function, you could write it in your preferred language and then look up the syntax for Solidity to convert it before entering it into your contract. So what exactly is a smart contract? A smart contract is a function as well as a contract that both sets itself up in terms of exactly what is required and so forth, and also enforces those like requirements. And it does so automatically in the sense that if I write a smart contract that always checks to see if the door is open or not, it will constantly run. And it will be triggered based on the conditions that I set for it, without me having to come back in and tweak anything. It will stay permanently there and continuously run until the blockchain is done, of course. But yeah. Any questions so far?
How do we add it to Azure again?
Pardon?
How do we add the zip file to Azure?
Oh, you added it to. Did you deploy? So this is the deployment right now. You can like come out of this. You can use open.
Okay.
Did you download the file?
Yeah.
Okay, so you can just open it in your IDE of choice, which is Atom. You can just open it in Atom and get to go from there. So we are not deploying this code to Azure. What exactly is going to Azure is our smart contract stuff, which is back to the project structure, is these smart contracts that is written within our Hackrates.sol and migrations.sol file. That is what we're going to publish to the Ethereum network on Azure, not the code itself. We'll probably, if you really want to put this project in production, you'll have to like deploy it through like regular web deployment services, such as Heroku or Microsoft Azure. Yeah. Solidity. So as every time we try to learn a new language, we always start with hello world. So this is hello world in Solidity. The first line, like HTML, you know, we have to like deduct HTML or whatever. We have to declare version Solidity. This case is diagnose Solidity, upper arrow, this, that, the other. Once again, you don't have to memorize this. Always Google and be like, what is the, you know, stuff like that. As well as this version of Solidity is pretty outdated as well. So another thing that I do is check the most recent version of Solidity and either go with that or use the one before that to be safe. So the file can have multiple contracts or one contract. If you have in one contract, we start that contract by saying contract, we name the contract, and we do the open bracket stuff, and everything within that open brackets is related to that contract.
So they could have more contracts, you could have more than one contract in one file?
Yes.
So how does it know which contract?
Once you have the starting line contract, is that data. But in terms of like what we learn in school, in terms of best software writing practices, you want to pull this out in separate files. good to go. Also, this is like the function syntax in the sense that within the contract, if you write this outside the contract, it probably wouldn't make any sense to solid Ethereum. So within the contract, we can write functions, we could declare variables, we can do anything we usually do in terms of software development. Specifically, this function, its purpose is to render hello world. And in doing so, you have the function tag, you name the function name, you have open brackets, and here, if you're returning anything within a function in Solidity, you have to declare what is being returned in the first line. By doing this, you can do return string. So you can always check the syntax for this and anything else you're trying to declare. Within, you have return hello world, and you ignore this semicolon, that's an error. Good to move on. Everyone up to speed? Good to go. Data types in Solidity, address. Everyone in the Ethereum network has an address once again, and this is its own data type in Solidity. For instance, in our contract we're about to write for voting, we can write a line that says sender equals voter equals sender.address. And that will give us the address of the person who submitted that vote without us having to do much. Once a contract is triggered, it will always have that address associated with it if you're playing with that contract. Does that make sense? Did I confuse anyone? Other types is uint, which is our typical integer stuff. We have string and we have struct. There are more types as well, but this is the pretty basic that we need to know. This project is pretty much a JavaScript-based project. So outside of the contract development, everything else is written according to Node.js, Express.js, JavaScript. Who doesn't know what Node.js is? Okay. We are all familiar with JavaScript. And JavaScript is somewhat the language of the web, outside of HTML and CSS, the actual functionality. And JavaScript has been used for like front-end development. But because of the potential power of JavaScript, frameworks will develop on top of it, such as Node, that will enable us to create secure back-end functions and back-end stuff using JavaScript. So this is pretty much a framework in the sense that we use, what is the framework we use in this? We use scalars. What's that?
The library.
Yeah. Oh, yeah.
Is Anaconda?
Yeah. Anaconda, I don't know. Okay. That's leading us in a different direction. So framework is pretty much someone, not us, sat down and create different like really nice entry points and exit points for us to do stuff using JavaScript without us having to look under the hood on how to create it secure. So that is Node.js for JavaScript. Everyone has Node installed on their computers. You can check by going to your terminal and writing node -- version. If not, you'll have to download Node for your relevant stuff. Node -- version -- v. Cool. I'm gonna proceed. Hopefully everyone has it. Now in our terminal or command line. Okay, another thing. You'll write npm install -g truffle solc. npm is the node package installer. Node package machine installer. -g helps us install this globally so that you can access it anywhere within your laptop. Truffle is the framework that we're going to use to compile and test our contracts. And SOLC is a Solidity compiler as well. If you have a permission error on Mac, type sudo npm install -g. I don't know what root. Oh. I don't know what errors you'll face on the Windows. Yeah. Hopefully you got yours too?
Oh, I think so.
Okay, cool. On Windows, I usually use Git, and that helps me. So when Azure created the blockchain, it also created a Coinbase account, which is like one of our entry points into cryptocurrency from the US specifically, where we can attach our regular bank account to a Coinbase, and we can pull our fiat money, which is US dollars, into Coinbase and purchase stuff like Ethereum, Bitcoin, and any other cryptocurrency that is hosted in Coinbase. This will be used to manage the transactions that we will have. All good so far? Did your Truffle and SOLC finish download?
So okay if there's a bunch of errors or
Yeah, ignore all the warnings. This is like an evolving space, so there will be a lot of warnings. Every 4 weeks there will be updates and so on. So now, everyone should check their Microsoft Azure portal and what's it? It's amazing. Where's MD? Okay, so when you check your Microsoft Azure portal, you'll know that it finished deployed because up here you'll see this sort of notification. If you see that, you know it's done. Is it done for most of us? Okay, cool. So from here, we want to click on resource groups, which is back on your left-hand side. If you're not seeing it, let me know. And once you click on resource groups, you'll see blockchain-lab algae. You click on that. you click on this already, and then so make sure you click on resource groups on the left-hand side, and you only need one line here. Oh, 8. You got 8?
I got 8.
You're in the wrong resource groups then. Let's see.
I think it's because you already clicked on the blockchain.
That's what you named it. Oh, okay. So if you get 8, go back to your left-hand side, look for resource groups. The first set of resource groups. Oh, okay, that should be good then. Okay. And you want to click on Microsoft-Azure-blockchain. Are you seeing that? Hopefully you didn't name it something else.
I named it
Wait, I think you click on deployments. Oh yeah, sorry. Click deployments first on the left-hand side. And then you should see the Microsoft Azure blockchain.
Can we do this if it's still on
Still
deploying?
deploying?
If it's still deploying, you wouldn't be able to do that.
So now I.
Then click anyway.
Oh wait, it just finished.
Perfect timing. Oh, it's still deploying, okay. If you want to start deploying, you can either follow along with what I'm doing on the screen and later on you can catch up, or wait with someone. Your deployment is complete. Moving on. Click on outputs, it's on the left hand side. And now you should see all these options on. Great. So this is where we do a bunch of like configuration of like MetaMask and Azure and stuff. If I lose anyone, tell me stop and so on. So return to your MetaMask window. Leave the Microsoft Azure open and just go to your MetaMask window. Expand the view. Expand view, click settings. What's happening?
What's different?
Oh, you gotta go on the MetaMask.
Good. Oh, okay. 1 second. So you should see the MetaMask icon. When you click on it, click expand view. Click the 3 dots, expand view. And this is what you should see. From there, let's see what happens after that. From there, you should see this. You click on the circle up on top. That should be like multicolored. Once you click on that, click settings. Got it? Settings? Wait. Sorry. You click on the circle, and then you can click settings. So leave this up, and we're going back to Microsoft Azure. Should have told you all this before. We want to copy the Ethereum RPC endpoint. Ignore this red, and this is an error as well. So we're going to copy this line by just clicking this blue. Done? Ethereum-RPC endpoint. Once that is copied on your clipboard, you want to go back to your MetaMask screen and paste the URL on the new RPC URL. You probably wouldn't see that because MetaMask was updated. You should see new network and then new RPC. You can paste it here. Is it pasted? Once you paste it, click save, and you should see a screen that pops up. If that doesn't pop up, do it again until you see it. Yeah. Did it pop up for you? Yeah. If it pop up for you, did it pop up for everyone? I had to do it like 4 or 5 times before I saw it. One second. Is that working? It wouldn't stay for too long. It would just be like a quick saying. That could be something too. Yeah, it should have something. Yeah, it says connecting to this, and then it disappears really quick. It disappeared really quickly for me when I did it. So if you try pasting and saving 4 times, that should do the trick if you don't see it. And you'll assume it was saved. And we just connected our MetaMask account to our Ethereum node in Azure. Woo! You can clap. Woo! You all made it further than a bunch of blockchain developers in the space. Now back to your Microsoft Azure screen. And this time you're copying admin site URL. It should be the first one on top. This is the address for the admin site for your Ethereum node that you have in Microsoft Azure. So this would be like your web view. Once you do that, you paste it in your browser's address bar, and you should see this screen. And this pretty much gives you your node status and so on. Have you seen that? Great. Anyone hasn't reached there yet?
But mine's still being saved.
Yeah, just good.
Or my thing's just still deploying.
Oh, okay. You can follow along with something and just see what I'm doing.
Okay.
And you have the slides too, so you can
All right.
watch afterwards. Any questions so far? Anyone lost in like what we are doing? Because we jumped around a lot. Okay. So you want to return to your MetaMask tab, and underneath this side of your side, 0x a bunch of stuff, and the copy and paste signal symbol, copy it. This is your address. So this address you can send to anyone in this room and ask for a donation from, and they can send you either or anytime. So once you copy that address, you want to go back to your Ethereum admin web view, paste that address in address of recipient, and click submit.
What the amount?
Yeah, you can leave the amount of 1,000. Click submit. Everyone there? And now you'll see your 200,000 ritual. If only. That'd be nice.
Why am I taking
Oh, okay. So you may see less now because the Ethereum is worth less at this minute. Ether is worth less. So everyone see that their account was loaded with money. Now we go back to the Microsoft Azure portal. We click, we save, we copy the SSH to first TX node, region 1. Yeah. At the very top of your Azure portal, you'll see this symbol. You want to click on this symbol. When you click on this symbol, you'll see something pop up at the lower end of your page, and you may be prompted to choose between Bash or PowerShell. Are you seeing that? Click PowerShell. You may also be prompted to create storage because you never used this before. So you just click create and put it in the Azure for Students subscription as well. Everyone here? Or pass here? Anyone not here? Okay, cool. So once your PowerShell has loaded, it might take a while because it's configuring and so forth. Once you get to a point of a prompt, you want to paste what's in your clipboard in it. And once you paste it, you click enter and it'll be triggered. It might say, do you want to trust this fingerprint on it? You click yes, you enter yes. Yes, so you can paste now and enter. And yes. I know. And you'll be prompted to enter your password. This is a password you set up Azure multiple times with. Yes, and password. Oh. The prompt you will see is PS Azure. You want to help? System restart required. Ignore the system restart required for now. But this you now entered into your VM, your Ethereum VM. What this is doing is entering you into one of the VMs that was created on Microsoft Azure. Anyone needs help at all? No? Oh. Yeah.
I'm still looking.
You're still looking it.
27 minutes now.
Wow. Microsoft don't like you.
Yo, you don't.
Wow.
I'm just doing
Yeah. You probably find it.
I don't understand hardware.
If I'm moving too slow, you can move forward with your presentation from your email. And if you have questions or anything, just ask me. Who hasn't made it here yet? Okay. You, Peyton? You? Okay, cool. Moving. MetaMask. In MetaMask, you can use both fake money and real money. For instance, like how we are playing around with the blockchain, we can use fake money right now in our attempt to learn. But you can also have real money there, and you just have to be conscious of
So when we said 1,000, we said fake money.
Yeah, fake money from the public, the testnet. That's a good question. Let's see.
On the top right.
Oh yeah, top right, you can see which network you're on.
Oh, I see.
Main Ethereum network, that's the real one, and everything else is pretty much test networks or your local computer.
That makes sense. Then, because this network, who's validating?
Ethereum organization. So the good thing about Ethereum is there's actually like a physical infrastructure for it. Like it's a company, so they have like constant people working on improving their protocol and so on. Unlike Bitcoin, which was just dropped.
Because the company itself is validated, because they're also doing mining.
Yes, yes. And Ethereum is interesting in the sense that they're trying to evolve the scaling issues. So although they still have proof of work, we saw they also launched proof of authority, and they have a bunch of other like protocols that they're trying to incorporate to like increase scalability issues or decrease scalability issues.
But doing that work, we're inherently also
Should be a thought.
Yes. Pretty much.
Is it at a sustainable level, or is it like the amount of money what it's putting into getting that?
It's very sustainable in the sense that everyone who got into blockchain early, even with the very basic idea, they have millions and millions of dollars. So that's why you'll see a bunch of blockchain companies just sponsoring people, just giving you money, just throwing events. Yeah, they have a lot of money right now. Although Ethereum company for like venture capital and like just community stuff is called Consensus, and they actually got rid of some of their startups they had incubated with them, which is because of how the market is like declining. Yeah. So that's interesting to see.
So how much do you think miners are being paid?
I actually have a mining farm. So it depends on Bitcoin is really tough to mine.
Yeah.
And you'll want the most powerful servers and stuff to mine that. But there are a bunch of the cryptocurrencies in the space where you can still make 10x plus. So it comes down to your mining farm capability to jump different cryptos based on like thresholds and so on. And it's hash rate in the sense that if you have a lot of machines running, you increase your chances and your likelihood to make a lot of money. Also, Trinidad and Tobago is the second cheapest place in the whole world to mine Bitcoin. So cheap electricity pays. Pardon?
It's cheap because it's
Electricity costs. So because of mining needs computing power, you need like for you to make actual money, you want to find the lowest electricity costs so you can increase your profit margins. The cheapest place is Venezuela, but it's not safe right now. So Venezuela.
Venezuela.
Yeah. Yeah. And the second is Trinidad and Tobago. And like I think it's 3 cents per kilowatt hour to mine. And roughly in like, I'm not sure on metrics, but you make money.
So then it's not on the cloud, it's all like physical.
Yes, it's physical. Like you pretty much have your own Amazon data center, and you have to like deal with heat and a lot of stuff.
Security guards for people.
Yes, actually, you actually need high security because it's like really expensive equipment. It's money, and like if anyone realizes how much money they can like do a whole raid. So moving on, you want to type GETH, get attach. This is a command to Ethereum. Let me get. So the get is short for Go Ethereum, and it's like a multi-purpose command for managing the Ethereum networks. So this, I strongly suggest going to your files and copying, or I can paste it in the WhatsApp message that you can fill up. So once you type get attach, sorry, the next thing you want to paste is this, where you substitute your password, the password for your password. Let's drop it in data science. There you go. You'll copy that and edit password to the password you set. Make sure no one sees it. And this command will unlock the Coinbase account we made earlier on. What time is it? 6:20. I know it's super late, so I wouldn't be offended if anyone leaves. You can always finish it up on your own as well. Where's the battery trick? That's what Ben says. What?
Thanks.
Ooh, damn. Once that's done, you know it's successful once you see true. And when you get to that point, you can click exit. You can type exit, run that, type exit again, run that, and you're out of your SSH. So a quick recap, we just created an Ethereum blockchain, or at least the entry point to an Ethereum blockchain on Azure. We created a MetaMask account, which gives us Ethereum to fuel our transactions that we're about to do. We unlocked our Coinbase account in the Microsoft Azure. And we also learned about Solidity, smart contracts, and Node.js to an extent. And now we move forward into inspecting and updating the code for our Hackrates app that we downloaded. So I will be wrapping it up at this point, where in redoing this, I ran through this presentation by myself today to see which errors came up based on updates. And I want to highlight that. So if you navigate your IDE, providing you exited your SSH, you go to truffle.js. And where it says your RPC endpoint here, you will want to go back on Microsoft Azure and copy your RPC endpoint and paste it there. That will look like, 1 second.
Can you put it in quotations?
Yeah, leave it within the quotations.
I was just gonna ask like how you kill everything or whatever.
I'm not going to review this code right now. Let's go to the IDE. So the biggest problem that you may face is because of how the Solidity keeps updating. You have to continuously update your contracts accordingly. So one biggest update that I realized we need to do is you can, within your migrations.sol file, which you can find within your, so go to your Truffle folder, then in Truffle, go to your contracts folder, and you'll see hackrates.sol and migrations.sol. Find all instances of constant. I already removed mine. Once you find all instances of a constant, replace that with view. If you're not using Visual Studio Code, hopefully your IDE has a nice shorthand for it.
How are you getting the search bar? I'm not familiar with
Command F.
Command F.
Yeah. So let's say you're in migrations.sol, you do Command F, and then you type in constant. On the left, you see this arrow you can put down and put view, and then you want to click this button on the end to change all instances of constant.
Okay.
You do the same for hackrates.sol.
I think the code got updated.
The code got updated?
The Hackrates one is
The Hackrates, there's one.
Oh, got it. Yeah.
Awesome. So you all should be good to go. My code was outdated. So in explaining this review, these contracts, this contract Hackrates has an event, which is it's similar to a function that is somewhat like a listener, like event listener. Are you all familiar with that? Right. It has a struct which keeps the rating. The struct encapsulates the rating that you'll submit. It has the project ID, the creativity value that you will submit, the test, the technical complexity and best practices, all of which is the uint data type that we explored before. This function adds the rating that your user will submit to the blockchain. 1 second. Yes. And this one is just a view function that gets the rating count. Moving along quickly, we have get rating. This function renders the rating for that specific project on your web URL, your web view, sorry. Did I move too quickly there? Good to go. So now it's time to compile and deploy this code. First, to do that, you'll want to, in your terminal, you want to cd into your folder, your project folder. You want to then cd into truffle again, and then you want to run truffle compile and then truffle deploy.
Truffle's so cute.
Yeah.
The word truffle.
It truly is. It changed lives.
Does something deploy?
In Visual Studio Code, which is really cool, you have a terminal there, so you don't even have to. You don't even need to like navigate. So if you look at the bottom here, you'll see this arrow stuff. You click terminal. One second. Are you seeing the arrow? Does that help? At the bottom of Visual Studio Code. Let me come. So that way you can save like CD in constantly. You still need to CD into your truffle folder and run truffle.
I couldn't even put the password in. I kept saying it was wrong.
One
That
second.
was great.
Yeah, my truffle have an error.
Your truffle has an error?
It won't deploy.
Let me check it. So those errors is potentially because of the project version, the Solidity version.
Mine, I think, was permission denied. I don't know enough about permissions. So I probably need to mod or something.
What error are you all seeing?
Truffle deploy, sorry, permission denied.
Okay,
And then
you have to do sudo.
They didn't want to.
Why would permission?
I don't know, but then it's like, push failed to do that.
Okay, so this one, yeah. This error is because of different compiler versions between. I actually came across that error today as well, so I haven't solved that yet.
Okay, so that just means I'm done and I'm always clear.
Anyone that did not get an error? Ready to truffle compile? It doesn't work for you? It doesn't work for me either, y'all. This is the issue with like when the Solidity keeps updating every 4 weeks. So now you have to like match everything. I'm still trying to solve this issue myself. Question?
I think you can just change
The version? Okay. Did it work for you?
Yeah,
Which version are you using?
I just used
0.5.0. Okay, so what Sean is saying, the version of Truffle or Solidity? Okay. So if you navigate to your contracts folder in both migrations and Hackrates, that's all. What you want to try is changing this to 0.5.0. This is one that worked for you. Great. And in both ones, make sure you save it and then try running it again. Truffle compile and then truffle deploy. Did it work?
I'm waiting.
If it went, yeah, it worked for me, y'all.
What did you do after you changed it to 0.5?
Save it. Save it in both files. It worked. Yeah, Charlie. Did it work for everyone else? The last thing you should see is writing artifacts to ./build/contracts, and then you want to do truffle deploy.
And when you do that, like, and it says, like, summary, total deployment, final cost, whatever. So that's the happens.
So, in your
migration and contract Hackrates, and you can see which documents we
Really good.
One is in this setup, which I'm not saying with this. So we have two blocks and a block, two blocks. They're almost blank templates, and one is actually. MLH actually provided the code for the contract. So what is the point is on this so you can't functionality to flow as no actual transaction. No transaction. So this is just here.
Remember when I was saying this? So once you deploy, what you essentially did, you remember that box that I was saying that you put on the blockchain that references your specific project. That is what you pretty much did. So when you deploy, you created a box for this specific project, and you will upload that to the blockchain.
According to like, I recorded a couple of things when I walked into the church at 5 a.m. and I also recorded when I walked into the restaurant. So then like what's it called? So maybe now the one I take it.
For a few years, and it was still like.
Everyone deploy their contract. It doesn't work. You already changed your point price.
You makes me
I
enjoy
think it's
Do truffle
that's
dash.
No, that doesn't work
we do
either.
the same thing, it gets stale, you know?
Oh, I see.
Oh, so you still have
Yeah. Yeah, you did too, right? Yeah.
If you were able to deploy a contract successfully, feel free to leave. You made it really fast. I will continue on still, and if you want to stick around, you can stick around as well.
I thought I did.
Any questions before anyone leaves? Any questions? Yeah.
Do we have to terminate anything?
1 second. Well, you have no credit card in Azure. So
But doesn't that eat away at like the free?
yeah. Let me see how you go about terminating this. We just have like 14 more slides to complete. Just super long. Now it's working? Cool. You did truffle compile already? Yeah, truffle deploy next. Yeah. Oh, so to test your app locally, we have like 2 more slides to complete. So let's continue on. And terminating, let's see. So before you close your Microsoft Azure, you want to delete the entire resource group, unless you plan to continue working on it. But delete it once you're done to save credits and so on.
Like both, like all of it.
Yeah, like just go in Microsoft Azure and just delete the entire resource group, which was blockchain lab-lab-rg. Okay, so if we did truffle compile and truffle deploy and it works successfully, we can go on to the next step, which is open index.js. On line 7, On line 7, we want to go back to Microsoft Azure and copy, let's see, index.js. Are you all seeing variable at a URL account password contract?
Yeah.
Okay, so we have to go back to our Microsoft Azure web portal. Click on resource scripts again. Blockchain lab. Why am I not seeing that? Deployments, Microsoft Azure, outputs. And we want to copy the Ethereum RPC endpoint. I'm going to paste that on line 7 within the quotation marks.
Which one are we copying?
The Ethereum RPC endpoint. This is the same URL you were supposed to put in MetaMask. Got it?
No, I think I'm missing something.
Should be able to.
Oh, okay. One more thing, Microsoft Azure, and then
Everyone, we copy that. Two more pertinent slides, but we can wrap up here. I will say 10 minutes. I can make it 10 minutes. I'm just taking once you copy that, you're going to put that in line 7 in the quotation marks. For line 8, we're going to copy and paste the address from MetaMask, which we get by copying here again. When you go to your MetaMask profile, you should see address. You copy that and you paste it in line 8 quotation marks.
Wait, but the first one that we copied
was,
yeah,
line 7. It should be ETA URL.
And then
line 8, the address from MetaMask. We should paste that in account. Everyone got that so far?
Yeah.
On line 9, you want to enter your password that you created in Microsoft Azure multiple times. Ooh. Everyone got that? Once you do that, save your file, and then you want to go back to your terminal and run Truffle Network. Once you run Truffle Network, you will see an address next to your Hackrates contract. Copy that address.
They're not liking this.
Copy that address and paste it on line 10 and save your changes. Did you follow that?
Wait, what's supposed to go in the contact address, or we wait to get out?
Yeah, if you have everything from line 7 to 8 and 9, 7 to 9, you save your file and then you go back in your terminal and run Truffle Network. Press it. If that doesn't work, let me know. See, we change once you all found the address next to your Hackrates contract. Yeah.
Like I did once.
That'd be great. And see since it's about to
Yeah, I did. It just happened in the
shuffle network. Yes. Okay, let's run shuffle the line again.
I don't. Maybe we have to do it in this one. This is like where it's working.
Once you make it to this point, and you add the address here, and you save that again, CD back to your main file, you can do npm install, and then you can run node index.js, and when you navigate to localhost :3000, you should see your very own version of the application on your local host. Yeah. There you have it.
Oh, I want to take my passports.
Really?
Yeah.
Cool. So pretty much at this point, if anyone have made it that far, you will be seeing this, your very own version of, where's this?
Yes, I think.
You'll be seeing your very own version of, nope. Where's this? Wow. 1 second. Oh yeah, rate my hack. This is what you should be seeing, and you have successfully made a decentralized application on the Ethereum network. At your own leisure, you can continue on. Feel free to message me anywhere if you have additional questions, and I will love your feedback on the workshop. Woo! Thank you.
I'm good.
Yeah,
Alright, I'll talk to you tomorrow. Let's know what's happening. Bye. Yeah, so, yeah.
have to do the same thing. Have you worked with something?
I did.
Should go back to your campus. This is a lovely relationship. But it's the same as you. Oh, they be in Azure. It likes Azure. Yeah. I thought I did. What do you think it was? Is it working for you, Dustin?
I don't know why we were. It's just the contracts have not been deployed to Azure, so.
Yeah, that's what mine says.
Yeah. Check my email.
Meg, where you at?
In my Amazon services. That's a different one.
What did you think of the workshop?
It was good, except I don't know why it wouldn't take my password. I was like, I dipped this in 4 times.
Wow.
Now that I can see it. But yeah, now I don't even know if you know any Amazon gurus. All of a sudden it won't connect to my sync session.
Because of that.
I don't know. Maybe it's like you, trader.
Wow. This is a putty problem. A very putty problem. Good to go?
Pretty good.
Cool. Let me see if I can troubleshoot this. RPC. Okay, so the RPC issue might be occurring because of that URL you were trying to paste in MetaMask initially, and we were looking for that pop-up.
Oh, so because we kept on doing it.
If you never saw that pop-up, it never got it.
Yeah.
Did you see the pop-up?
Yeah, I don't think I did, but then.
It allowed me to keep going though.
It allowed you to keep going, but you never.
Yeah.
Yeah. So to potentially fix it, you could just try piecing it again in MetaMask. When you go to your Microsoft Azure portal, you do the whole jump until you get to output. You remember that flow? So this is where you want to paste. This is where you want to paste it, and then in Azure. What do you say, Azure? Azure. Yeah, you wanna copy Ethereum RPC endpoint from outputs and paste it. What do you thought of the presentation? Cool. Anyone take it? Let me check. Refresh. If you still don't see a pop-up, my suggestion will be to reload your website. Maybe disable pop-ups. Put that earlier so it's on the website. But... I get the gist.
Oh, damn.
You got it?
Sending them all one by one.
Azure. Don't need to apologize. That's why I'm.
Why should I just put it in?
Like one
What's
big
that?
thing.
Just